Good morning, students. Dear students, in the previous video, we had discussed about motion, uniform motion, non-uniform motion. Then we had discussed about speed, what is speed, and after that we had solved a simple numerical based on this. Now, today we are going to discuss the vector form of speed, that is velocity. Today we will discuss about velocity, and as I had told, that is vector form of speed. Vector form of speed means when direction is included with the speed, and when the direction is included with the speed, when we are talking about the displacement, suppose I am clarifying with this coordinate axis. This is x axis and this is y axis, and these are 2 points, point A and point B. These are 2 points, and suppose an object is moving in this way from A to B, then here you can't say the direction of motion from A to B, and in this case we have to consider this is time axis and this is displacement or distance axis. So in this case we will discuss about the path length covered or distance covered upon the time elapsed. Then we are talking about the shortest distance between these 2 points, then we have to talk about its speed. Then we have to talk about its velocity, and the velocity is rate of change of displacement. Displacement means the shortest distance between A to B. Suppose from this origin the position vector is x1, and from the origin the position vector is x2, then this is the displacement is final position x2 minus x1. This final position is x2 minus x1, and from here you can see that this is suppose this position is x1 x2, this position in displacement time on the displacement axis, on y axis this displacement is x2 and this displacement is x1, then the difference is x2 minus x1 upon this time is t2 and this time is t1. The time interval delta t is t2 minus t1. The difference means at time t1 the object is at its position x1, which is called as its position vector, and at time t2 the object is at point B, which is x2 meter. So the net displacement is x2 minus x1. Now displacement is velocity is given by velocity v is given by displacement upon time, or you can say that rate of change of displacement, rate of change of displacement. So displacement is what? Displacement is equal to x2 minus x1, and time is t2 minus t1. That is delta x, which is displacement, upon delta t, which is change in time. x2 minus x1 is the change in position, that is displacement, and t2 minus t1 is delta t, that is change in time, and it can be given by the slope theta, that is equal to tan theta, the slope, that is equal to x2 minus x1 upon t2 minus t1. This slope gives the velocity, means slope of displacement time graph gives velocity. Slope of displacement time graph gives velocity. So rate of change of velocity is called as rate of change in position or displacement of an object with time is called as velocity. And since it is the vector analogous of speed, since it is vector analogous of speed, so it is a vector quantity. I think it is clear to you all. It is a vector quantity. So note it down. Rate of change in position or displacement is called velocity. Rate of change of position or displacement is called velocity along with time. So velocity is equal to displacement velocity is equal to displacement upon time. Now, as we had discussed that displacement can be positive, negative or zero. So as delta x displacement can be positive, negative or zero, so velocity can also be positive, negative or zero. So velocity can also be positive, negative or zero. Its SI unit is meter per second. Displacement in meter and time in second. So SI unit is meter per second and CGS unit is centimeter per second. SI unit is meter per second and CGS unit is centimeter per second. Dimensional formula is same as dimensional formula same as speed. Its dimensional formula is same as speed, that is mLt minus 1. Now uniform velocity as simple as that. Equal displacement in equal interval of time. Equal distance we had discussed in case of speed also quite in detail, so I need not to specify this particular thing here. And non-uniform velocity unequal displacement in equal interval of time. Unequal displacement in equal interval of unequal displacement in equal interval of time. Suppose in the first second 2 meter, second 5 meter, third second 3 meter. So in this way the object is changing its position, then such type of velocity is called as non-uniform velocity. So this is something about velocity. Now let us discuss a good numerical over this velocity. Note it down and try to solve it by your own. Example: during a hard sneeze, your eyes must shut for 0.5 second if you are driving a car with 90 km/h during such a sneeze. During such a sneeze, how far does the car move during that time? Means you have to find out the distance, the speed it is given. You are sneezing, a hard sneezing while driving, you are sneezing and your eyes shut for 0.5 second. Then if your car is, you are driving a car 90 km/h, then during such a sneeze, how far does the car move during that time? The first and foremost thing is to change 90 km/h into meter per second. 90 km/h into meter per second. Look at here. Given t is equal to 0.5 second, v is equal to 90 km/h, a is equal to what? Delta x is equal to what? What is the displacement in that time you had covered? You have to find out that displacement. So 90 km/h, 90 km/h. It means to 90 into 1000 meter into 1 upon 60 into 60 second. That is equal to 90,000 upon 3600 meter per second. (25 meter per second). In meter per second, 25 meter per second. Now you then know that velocity is equal to delta x upon delta t, delta x upon delta t. So you have to find out delta x. Delta x is equal to v into delta t, and velocity is 25 meter per second into 0.5 second, that is equal to 12.5 meter, approximately equal to 13 meter. Means during that sneeze you will travel a distance of 13 meter. And next, very good question. This question is good question. Try to solve it. Look at here. Two trains each having a speed of 30 km per hour are headed at each other on the same track. A bird that can fly that 60 km per hour 60 km per hour flies off the front of one train, when they were 60 km apart and heads directly to the other train. On reaching the train, bird flies back to the first train. What is the total distance? The bird travels before the train collide. Two trains having the same speed, that is 30 km per hour, and both are heading on each other on the same track, means both are facing in the same direction. The engine of both the trains are in the same direction on the single track, and both have the same speed. A bird that can fly 60 km per hour flies off the front of one train. A bird is sitting on the front of one train and flies towards the other train when they are 60 km apart. When they are 60 km apart, the bird starts flying from one train to the other train with a speed of 60 km per hour. On reaching the bird flies back on the same train, first train. So the bird continuously starts flying from one train to other train. After the distance between the trains is 60 kilometer. Then you have to find out the total distance the bird traveled before the train collides. It is obviously that the train is facing towards each other, then it must be the chance that they will collide. So before collision between those both the trains, what is the distance traveled by the bird? So let's do the calculation. This is one train. The separation between them is 60 kilometer. This is bird. Bird starts flying 60 kilometer per hour from one train to another train. V1 is given, that is 30 kilometer per hour, that is equal 30 into 5 upon 18 meter per second. 8.33 meter per second, and V2 is equal to 60 kilometer per hour. This is the speed of the train and this is the speed of the bird. So 60 into 5 upon 18 meter per second, and it will be 16.67 meter per second. 16.67 meter per second. The total separation D is 60 kilometer, means 60,000 meter. All the quantities we had converted into meter and meter per second. So first of all we want to calculate the time. What is the time? So velocity equal to delta x upon delta t. Velocity is equal to delta x upon delta t. So delta t is equal to delta x upon v. By reading the question carefully, you realize that you have two unknowns that need to be solved, that is time and the second one is displacement. So first of all we are calculating the time of collision of the train. So for the time of collision of the train, velocity of the train is 8.33 and the distance we have to find out. What is the distance? So delta T 30,000 upon 8.33, that is equal to 3,600 second. 3,600 second. Now the time for average V is equal to, again V is equal to delta x upon delta t, or delta x is equal to V into delta t. So delta x is equal to V into V is, we had calculated 3, velocity of the bird is 16.67 16.67 meter per second, and in 3600 second, and it will give the velocity 60,000 meter, that is equal to 60 kilometer. 60 kilometer means both the velocities v1 and v2 we had distance we had found, and before the collision, as both are since both have the same speed, so it will travel 30 kilometer and it will travel 30 kilometer, so delta x is equal to 30,000 kilometer, and both have the same speed, that is 8.33, which will give the velocity 3600. Now the time of collision we had got. If we had got the time of collision, then in that time how much distance the bird is going to travel. So that distance delta x is equal to velocity of the bird. Velocity of the bird is 16.67 meter per second into the time we had calculated, time of collision. With this velocity the time of collision is being multiplied, and after that you had got 60,000 meter, that is 60 kilometer is the 60 kilometer is the distance traveled by the bird from one train to other train before collision of the train. So I think it is clear to you all. First of all, we had calculated the velocity in meter per second, then we have calculated the time for the collision of the two trains, and that time we have got 3600 second, and in 3600 second with the velocity 16.67 meter per second, the bird will travel a distance delta x, that is equal to 60 kilometer. So this is the numerical section. Now positive and negative velocity, I am going to discuss positive and negative velocity. This topic today I am discuss, then in the next video I will discuss about average velocity and average speed. So positive and negative velocity. Positive and negative velocity. In the previous question, that question, it is not necessary to convert in meter per second. If you want to calculate in kilometer per hour, then it is easier for you to calculate in kilometer per hour. The answer will be the same. So if you want to calculate in kilometer per hour, then you can calculate in kilometer per hour also, and your answer will be the same. Now positive and negative velocity. Positive and negative positive and negative velocity. Positive and negative velocity. Positive velocity means nothing. Positive velocity. Positive velocity. Positive velocity means nothing. If final position is greater than initial position, means if displacement is positive, then the velocity is positive. So if displacement is positive, then here origin at time t1 position is x1, time t2 the position is x2. X in meter and time in second. X in meter and time in second. Now the slope, as we had discussed about the slope slope, that is equal to this upon this, x2 minus x1 upon t2 minus t1. Slope x2 minus x1. So if x2 is greater than x1, x2 is greater than x1, then x2 minus x1 is equal to positive. x2 minus x1 is equal to positive, and slope is positive. Slope is positive. Then slope is positive. And if the displacement is negative, negative velocity, negative velocity means, suppose this is plus 70 and the body reaches, this is at time t1 and this is at time t2, plus 10. So x2 is less than x1. The velocity is equal to x2 minus x1 upon t2 minus t1. This is the slope. Tan of this angle is always negative, and in the previous case it was like that. Tan of this angle is positive, so it is positive velocity, it is negative velocity. The x2 is 10 and x1 is 70 upon, suppose t2 is 5 minus 3, so it will give the negative value. So in this case, if final position is smaller than the initial position, then the slope is negative. The slope is negative, and so it is called as negative velocity. If the final position and initial position is same, then x2 minus x1 is equal to 0, and x2 minus x1 is 0, then in that case the velocity is 0, and that case is the no velocity. In that case we say that the body had no velocity. So this is about velocity, positive and negative velocity. Now in the next video we will discuss about average velocity and average speed. So that's all for today, students. Take care. Have a nice day. Thank you, students.